About 65,000 years ago, Australia probably became the worst place on Earth to be alive. Cut off from the rest of the world for millions of years, its creatures had turned monstrous. Birds that could shatter bone, kangaroos that stood 10 feet tall, crocodiles that ran down prey on land and sliced through bone with blade-like teeth. Even the streams hid 6-foot salamanders with jaws like bear traps. This was the late Pleistocene, an era of global ice, rising deserts, and vanishing rain. While glaciers advanced elsewhere, Australia dried out and burned. Its ecosystems buckled under the pressure, and what remained was a continent built for giants and wired for extinction. And when Homo sapiens finally arrived, they were walking straight into an extinction machine. At the heart of Australia's prehistoric ecosystem stood a bird so large, so anatomically strange, that scientists were unsure whether to classify it as comical or catastrophic. Its name is Bulacornis planae, a member of the family Dromornithidae, and one of the most massive flightless birds to ever walk the Earth. Fossils dated to the Middle Miocene, approximately 15 million years ago, were first unearthed in the Alcuda fossil beds of the Northern Territory. Complete skeletal reconstructions suggest this bird stood over 2.5 meters tall and weighed between 450 and 500 kilograms, comparable in mass to a modern-day polar bear. But it was the skull that stunned paleontologists. Measuring nearly half a meter in length, the beak of Bulacornis was deep, wide, and sharply edged. Its bite force has been estimated to rival that of large herbivorous mammals. And while some researchers argue for a primarily plant-based diet, the morphology of the skull, particularly its laterally compressed, cleaver-like beak, has led others to propose omnivory or even opportunistic scavenging behavior. Its nickname, coined by the media and echoed cautiously in scientific circles, reflects this ambiguity: the demon duck of doom. Although Bulacornis looked more like a giant emu, studies show it was actually more closely related to ducks and geese, having evolved from ancient waterfowl that took a very different path in isolation. With no large terrestrial mammalian predators, birds filled multiple ecological niches, including that of heavyweight browsers and possible megafaunal competitors. Unlike modern kangaroos or marsupial predators, Bulacornis did not rely on speed. The structure of its limbs indicates it was a slow-moving but powerfully built ambush specialist, possibly using its sheer size and crushing beak to defend territory or claim carcasses. Evidence of pathologies in fossilized bones also suggests frequent high-impact collisions or intraspecies conflict. The Alcuda fossil beds, rich in Bulacornis remains, also preserve the bones of other massive dromornithids, indicating a long and competitive evolutionary arms race among Australia's flightless giants. Although Bulacornis was extinct millions of years before the first humans arrived, its close relatives like Genjornis Newtoni persisted into the late Miocene and Pliocene, and other large avian threats like Genyornis Newtoni were still present in the late Pleistocene. These creatures likely shaped early Aboriginal mythologies and survival strategies. In a continent where birds could weigh half a ton and where herbivores evolved weapons rivaling those of predators, the simple act of walking through open country could trigger a life-or-death encounter. Bulacornis is a reminder that, in prehistoric Australia, even the herbivores were dangerous, and the birds were unlike anything else on Earth. If Bulacornis showed that birds in prehistoric Australia evolved toward power and aggression, its mammalian neighbors took a similar path, only they did it on 2 legs and with bone-crushing strength. The largest of them was Procopadon Goliath, the biggest kangaroo species ever discovered. Fossils of Procoptodon have been unearthed at multiple late Pleistocene sites across Australia, including Lake Calabana and Cuddy Springs, and radiocarbon dating places its extinction around 46,000 years ago, within a few thousand years of the first arrival of Homo sapiens. Unlike modern kangaroos, Procoptodon didn't hop in the same way. Its foot bones were broad, with a single hoof-like toe that suggests it walked upright with a long, bounding stride. Standing over 2 meters tall and weighing more than 230 kilograms, it would have towered over most humans and outweighed a modern red kangaroo by more than double. But it wasn't just size that made Procoptodon remarkable. Its skull was short and deep, with forward-facing eyes and an enormous pair of incisor-like teeth that flared forward. Behind them were crushing molars adapted for grinding tough, fibrous plants during periods of drought, a trait confirmed by microscopic wear patterns on fossilized tooth enamel. Its forelimbs, though shorter than its legs, were thick and heavily muscled, ending in 2 large curved claws. Researchers believe these were used for pulling down branches and possibly for defense. Some reconstructions even suggest the arms were strong enough for grappling, an unusual trait for a herbivore. Analysis of fossil trackways and joint structure indicates that Procoptodon was not a fast animal, but its sheer bulk and strength would have made it difficult to challenge. In a drought-stricken environment, this kangaroo would have needed to travel long distances to find food and water, potentially bringing it into competition with other megafauna, or early humans. Paleoclimatic data shows that the late Pleistocene in Australia was marked by extreme variability, with intensifying aridity and the collapse of major plant communities. In this context, Procoptodon's specialized adaptations to dryland browsing may have made it both more successful and more vulnerable. Isotope analysis of bone collagen suggests that Procoptodon fed primarily on leaves from saltbush and chenopod shrubs, plants common in semi-arid zones. As inland Australia became increasingly dominated by desert and spinifex, these high-energy food sources dwindled, leaving even giants like Procoptodon at risk. Its extinction, like that of many megafauna species on the continent, is still debated. Some researchers point to rapid environmental shifts, others to the spread of fire-based land management by Aboriginal populations, and some to direct hunting pressure, though definitive kill sites remain scarce. What is clear is that Procoptodon was one of the last holdouts in a collapsing ecological order. It represents a version of Australia's mammals that has no modern equivalent, upright, powerful, specialized, and unchallenged for thousands of years, until the balance tipped. While Procoptodon ruled the dry inland plains, it shared the late Pleistocene landscape with another towering survivor, one that bore feathers instead of fur, but matched its neighbors in both size and menace. This was Genyornis Newtoni, the last known member of the Dromornithidae family, a lineage of flightless birds that had dominated Australia for tens of millions of years. Standing up to 2 meters tall and weighing approximately 230 kilograms, Genyornis was roughly the size of a modern-day ostrich, but far more powerfully built. Its thick legs, stocky frame, and dense bone structure suggest it was not a runner, but a walker, adapted for stability over speed. Fossils of Genyornis have been discovered at numerous sites across Australia, including Lake Calabana, Lake Eyre, and the Darling Downs. Many of these remains are found in association with megafauna species like Diprotodon and Zygomaturus, indicating that Genyornis occupied the same arid and semi-arid environments as the continent's largest marsupials. Its most distinctive feature was its deep, heavy beak, broad, sharply downturned, and capable of delivering powerful bites. Though once thought to be herbivorous, wear patterns and skull mechanics suggest that Genyornis may have supplemented its diet with small animals, eggs, or carrion, placing it somewhere between a grazer and a generalist omnivore. Unlike its older relative Bulacornis, Genyornis lived during a time of mounting ecological stress. The fossil record shows a sharp decline in the species around 47,000 years ago, closely coinciding with both increased climatic aridity and the arrival of humans. One of the most compelling pieces of evidence linking Genyornis to early human activity comes not from bones, but from eggshells. Scattered across ancient dune fields in South Australia and Western Australia, archaeologists have uncovered burned fragments of Genyornis eggshell, dated to around 50,000 years ago, using optically stimulated luminescence, OSL. The thermal damage on these fragments is highly localized, matching what would occur during brief cooking over open fires. This has led many researchers to conclude that early Homo sapiens collected and cooked Genyornis eggs, a practice that, while small in scale, could have had catastrophic consequences for a species with slow reproductive cycles and few natural defenses. Combined with habitat loss and increased fire frequency, this pressure likely pushed Genyornis beyond recovery. By 45,000 years ago, it disappears entirely from the fossil record. Its extinction marked the end of a lineage that had dominated the continent for nearly 30 million years. And while no written records or cave art preserve its image, the fossilized eggshells, heavy leg bones, and sediment profiles tell a clear story. In prehistoric Australia, even the birds were giants. And in the struggle between endurance and environmental collapse, no creature, not even one armored in feathers and muscle, was safe for long. Long before the rise of Genyornis, and millions of years before Procopadon ever walked upright across the plains, Australia's waterways were ruled by a predator unlike anything alive today. Its name was Kulasucus clelandii, the last known representative of an ancient lineage of giant amphibians called temnospondyls, a group that first appeared more than 300 million years ago in the Carboniferous period. Kulasucus lived during the early Cretaceous, around 120 million years ago, in what is now the state of Victoria. At that time, southeastern Australia was located within the Antarctic Circle, yet fossil and sediment evidence suggests the region remained ice-free due to elevated global temperatures during the mid-Cretaceous greenhouse climate. The environment was seasonally cold, marked by long winter darkness and frigid river systems, conditions inhospitable to most large cold-blooded predators. But Kulasucus was adapted for just that. Fossils recovered from the Dinosaur Cove site along Victoria's southern coast include partial skulls and vertebrae, from which paleontologists estimate the animal reached lengths of 4 to 5 meters, with a massive, flattened head nearly a meter wide. Its jaws were lined with conical teeth and internal palatal fangs, traits common among aquatic ambush predators. This configuration suggests it preyed on fish, small reptiles, and possibly juvenile dinosaurs near the water's edge. Scientifically classified within the family Chigutisauриdae, Kulasucus represented one of the last known temnospondyls to survive into the Cretaceous, an outcome that surprised paleontologists. Elsewhere in the world, temnospondyls had largely disappeared by the end of the Triassic, but in southern Gondwana, this lineage persisted, likely thanks to its ability to thrive in cold, low-competition river ecosystems. One key reason for its success may have been the absence of crocodilians. Fossil evidence indicates that crocodiliforms, which dominate many warm water ecosystems, were largely absent from polar southern Australia during this period. Kulasucus, by contrast, was well suited to colder conditions, possibly even hibernating during the long, dark winters. Sedimentological data from its fossil sites, rich in claystone and fine-grained silt, suggest a slow-moving, meandering river system, bordered by lush conifer forests and ground ferns. The presence of floodplain deposits, preserved root traces, and ripple marks all support a stable, well-oxygenated aquatic environment, ideal for ambush predation. Despite its dominance, Kulasucus would not survive beyond the early Cretaceous. By the late Cretaceous, rising temperatures, habitat loss, and the spread of more advanced reptiles, including crocodiliforms, likely outcompeted these amphibians into extinction. Still, its legacy remains striking. Kulasucus was not only one of the last of its kind, it was the largest known amphibian to exist in the southern hemisphere during this era. And in a continent famous for producing strange evolutionary offshoots, it stands as proof that Australia's history of monstrous, ecosystem-defining predators began not with mammals or birds, but in the water. When Kulasucus vanished in the late Cretaceous, it left behind a vacant throne in Australia's freshwater ecosystems, one that would eventually be filled by reptiles far more familiar to modern eyes, but no less dangerous. Among them was Palamarcus pollens, a massive semi-aquatic crocodilian that dominated river systems across northern and eastern Australia during the Pliocene and Pleistocene epochs, between 5 million and 40,000 years ago. First described in the 1920s from fossil remains near the Mary River in Queensland, Palamarcus is known from partial skulls, vertebrae, and osteoderms. bony plates embedded in the skin. Based on these remains, paleontologists estimate it reached lengths of 5 to possibly 7 meters, making it comparable in size to modern saltwater crocodiles, but with distinct anatomical features that suggest different behavior and ecology. Unlike today's Crocodilus porosus, which relies heavily on ambush tactics and marine or estuarine habitats, Palamarcus appears to have been more heavily built, with a broader snout and adaptations better suited to slow-moving inland waterways. Its thick skull bones and robust teeth point to a predator capable of tackling large terrestrial animals, including juvenile Diprotodon, a hypothesis supported by overlapping fossil distributions. Sediment analysis from fossil sites such as the Bluff Downs fossil locality in northern Queensland reveals a once wet landscape filled with permanent waterholes, oxbow lakes, and forested riverbanks. These calm, resource-rich environments would have provided ideal hunting grounds for a crocodile that didn't just wait in ambush, but could also assert dominance over large stretches of territory. In several locations, Palamarcus remains are found in close association with other megafauna, including Zygomaturus, Protemnodon, and large flightless birds like Genyornis. Although no direct evidence of predation has yet been discovered, the sheer size and strength of this reptile, combined with its proximity to such species, makes it a prime candidate for opportunistic or active hunting. As with many of Australia's large Pleistocene fauna, the extinction of Palamarcus likely coincided with the arrival of Homo sapiens and rapid environmental shifts. By around 40,000 years ago, it disappears from the fossil record, replaced by the modern Crocodilus species that dominate northern rivers today. But in its time, Palamarcus was likely the apex predator of inland Australia. It was not restricted to swamps or coastal estuaries. It roamed wide river systems, outlasted Ice Age droughts, and may have played a key role in shaping the behavior and movement of prey species across the continent. It turned rivers into hunting grounds, and in this land, even the water was no joke. While Palamarcus ruled the rivers, Australia's dry forests and scrublands were home to a predator unlike anything alive today. It was neither feline nor placental, but its strength, anatomy, and hunting strategy have earned it a reputation as one of the most fearsome mammalian carnivores of the Pleistocene. Its name was Thylacoleo carnifex, literally the meat-cutting pouched lion. Discovered and named in the mid-19th century, Thylacoleo has long fascinated paleontologists for its unusual combination of traits. It belonged not to the order Carnivora, but to the Diprotodontia, the same order that includes wombats and kangaroos. Despite this herbivorous ancestry, it evolved into a specialized predator, capable of bone-splitting force and stealth ambush. Fossils recovered from sites such as Wellington Caves, Narakorte Caves, and the Nullarbor Plain indicate that Thylacoleo reached lengths of 1.5 meters, stood about 75 centimeters at the shoulder, and weighed up to 130 kilograms, roughly the size of a modern jaguar, though more heavily built. Its skull is perhaps the most striking aspect of its anatomy. Unlike cats or canids, Thylacoleo lacked true canine teeth. Instead, it had two enlarged, incisor-like blades at the front of the jaw, and an extraordinary pair of shearing premolars at the back. These molars were laterally compressed and honed against each other like scissors, forming a pair of natural meat cleavers. Bite force analysis reveals that, pound for pound, Thylacoleo had the strongest bite of any known mammal, extinct or living. Estimates suggest its jaws could exert more than 1,000 pounds of force, more than enough to crush bone or sever spinal cords. Its forelimbs were just as deadly. Each paw ended in retractable claws, with a large curved thumb claw capable of inflicting deep wounds or securing prey during a grapple. Combined with strong shoulder musculature and semi-opposable thumbs, this gave Thylacoleo excellent climbing ability and grip strength. Trackways found in places like Lake Calabana suggest it was a deliberate low-slung walker, likely an ambush predator rather than a pursuit hunter. Some researchers believe it may have climbed trees to stalk prey from above, leaping down with crushing force. Others suggest it ambushed from thick underbrush or rocky outcrops, using stealth, strength, and a surgical kill strategy. Despite its size and weaponry, Thylacoleo was not invincible. Its extinction, like that of many of Australia's megafauna, is dated to around 46,000 to 40,000 years ago, roughly coinciding with climatic shifts, the expansion of fire regimes, and the arrival of humans. No definitive kill site has been linked to human hunting, but the absence of Thylacoleo from Holocene records, combined with cave art from Arnhem Land that may depict lion-like creatures, suggests it may have persisted long enough to enter the early Aboriginal imagination. In evolutionary terms, Thylacoleo represents a rare reversal, a marsupial from a plant-eating lineage that evolved into a top-tier carnivore. It had no direct analog and no descendants. And in Ice Age Australia, it may have been the only land predator that could stalk and kill with the efficiency of a lion, without being one. By 40,000 years ago, the silence had begun to spread. Species that had ruled for millions of years, Bulacornis, Procopadon, Genyornis, Thylacoleo, and Palamarcus, began vanishing from the fossil record in rapid succession. This wave of extinction swept through the heart of the continent, eliminating over 85% of Australia's megafauna within just a few thousand years. The causes remain debated, but the evidence points to a lethal convergence: a drying climate, more frequent and intense wildfires, and the arrival of Homo sapiens, whose hunting, land clearing, and fire-based management reshaped entire ecosystems. Charcoal deposits in sediment cores show a spike in fire activity after human arrival, suggesting landscapes once dominated by dense vegetation were replaced by open grassland. Stable isotope analysis reveals dietary stress in large herbivores as nutritious plants declined, and archaeological sites across the continent tell a consistent story. Once common megafauna vanished, leaving only fragments behind. Australia had always been harsh, but by the end of the Pleistocene, the balance had tipped. The giants were gone, and what remained was a continent transformed, no longer ruled by thunderous footsteps, but by fire, wind, and silence.